Welcome students to our today's lesson on isotopes and RIAM. Isotopes. These are atoms of the same element with the same atomic number but different mass numbers. They can also be defined as atoms of the same element with the same number of protons but different number of neutrons. Examples of elements with isotopes are hydrogen, chlorine, carbon, oxygen, silver, etc. Now, let's move on to relative atomic mass. Relative atomic mass is the average mass of an element compared with an atom of a single carbon-12, the mass of which is 12. So, relative atomic masses are masses of other atoms of elements compared to the mass of an atom of carbon-12, which is 12. When calculating relative atomic mass of an element, it can be a fraction because it is an average mass of the isotopes of the element. Therefore, when it is a fraction, don't be worried. It can be a fraction because it's a comparison. Relative atomic mass is measured accurately using an instrument called the mass spectrometer. And the results obtained from such an instrument are known as mass spectrograms. Therefore, we have two new terms here. The instrument used to measure relative atomic mass and the name of the results obtained from the instrument. That is mass spectrometer, and it measures in units known as mass spectrograms. A mass spectrometer can also be used to obtain relative abundances of isotopes. In other words, the percentages of the atoms of the isotopes. Relative atomic mass is always close to the most abundant isotope because the most abundant isotope is the one which contributes more to the relative atomic mass. So you'll find that the figure you are getting of the relative atomic mass is closer to the most abundant isotope. That isotope which has a bigger percentage in terms of abundance is the one which is usually closer to the relative atomic mass. Example 1. Chlorine is made up of two isotopes as follows. Chlorine 35 with a percentage abundance of 75% and chlorine 37 with a abundance of 25%. The formula for calculating RIAM is, so the relative atomic mass will be percentage of isotope 1 times, that is P1M1 plus P2M2 over 100. P1 is percentage of isotope 1. M1 is the mass of isotope 1. P2 is percentage of isotope 2. M2 is the mass of isotope 2. So the RIAM of chlorine will be equal to 35, the mass 1 times 75 in bracket plus the percentage 2 is for chlorine 37 times a relative abundance of 25 in bracket, all this over 100. So this is going to give us from your calculator 2625 plus 925 over 100. And when you add this and divide by 100, you are going to get 35.5. So that is the RIAM of chlorine. And you see it is closer to the most abundant isotope, which is 35. It has a percentage of 75. So it is closer to the most abundant isotope. Now, the RIAM of chlorine is 35.5. Calculate the relative abundances of its isotopes, chlorine 35 and chlorine 37. Now this involves working backwards, and this is how we do it. So let the abundance of chlorine 35 be x. Then the abundance of chlorine 37 will be 100 minus x. So the RAM will be equal to 35 times x plus 37 times 100 minus x, all this over 100. And because we already have the RAM given as 35.5, let us replace RAM 35.5 should be equal to 35x plus 3700 minus 37x, all this over 100. Now we put like terms together. No, first of all we cross multiply to remove the denominator. So this is going to be 3550 is equals to 35x plus 3700 minus 37x. Now like terms together, we can bring the x's on this side. It's going to be minus 35x plus 37x is equals to 3700 minus 3550. So minus 35x plus 37 is 2x is equals to 3700 minus 3550. The calculator. So 3700 minus 3550 is 150. So over 2 over 2. X is going to be equal to 75%. So chlorine 35 is 75%. Then chlorine 37 will be equal to 100 minus 75, which gives us 25%. So that's how you work out that one. Example 2. An element X has an RAM of 20.2 and has two isotopes X20 and X21. Which is the most abundant isotope? Now that one we can answer by looking which of the two values is closer to 20.2, between 20 and 21. So you realize that it is 20. 20 is closer to 20.2 than 21. Therefore, the most abundant isotope is usually the one closer to the RAM, so it is X20. Now, calculate the percentage of the most abundant isotope. Now, this is how we work it out. So, we are going to work out this way. We have the RAM is equal to, let this one have an abundance of X. This one will be 100 minus X. So the RAM will be equal to 20 times X plus 21 times 100 minus X. Vizuri kuiweka in brackets. So the RAM is already given, so we have 20.2 is equals to 20x plus 2100 minus 21x. All this over 100. Sorry, I had forgotten. This over 100. Cross multiply at this point to remove the denominator. So this is going to be 2020 is equal to 20x plus 2100 minus 21x. Like terms together, you can bring 21 this side so that it will be 2020 minus 2100 is equals to 20x minus 21x. So 2020 minus 2021, this one is going to give us 2020 minus 2100 is 80 is equals to negative 1. No, yeah, negative 1. So x, the negatives cancel out, so x is equals to 80%, and x is the most abundant, so the most abundant has 80% abundance. Example 3. Boron has two isotopes, B11 and B10, which occur in the ratio 4:1. Calculate the RAM of boron. Now this is how we work this one out. So we will come and say RAM is equals to boron 11 times 4 plus boron 10 times 1, then all this over the total of this ratio, which is 5. So it is 44 plus 10 over 5. So this is 54 over 5, which is equals to 10.8. So the RAM of boron is 10.8. Element M has two isotopes with mass numbers 25 and 29 respectively. The RAM of M is 28.078. Determine the percentage abundances of the isotopes. Now this one we work out similar to example 2, and this is how it's going to be worked out. So M25, let the abundance be x, and M29, the abundance will definitely be 100 minus x. RAM is given as 28.078. So we shall come and say 28.078 is equals to 25 times x plus 29 times 100 minus x, all these over 100. So 28.078 equals 25x plus 2900 minus 29x, all this over 100. Remove the denominator. This is going to be 2807.8 is equals to 25x plus 2900 minus 29x. So if you put like terms together, you are going to have minus 92.2 is equals to minus 4x. You can confirm that using your calculator. Divide by minus 4, divide by minus 4. So our x will be equal to about 23.05%. So x was M25. 23.05%, while M29 will be 100 minus 23.05%, and it gives us 76.95%.